Hello, our fourth circuit. Welcome. This now is the electric gate controller using PIC16F819 microcontroller. As we can see, this microcontroller, we have a program running inside here with a relay driver driving two relays, forward and reverse, and then you have a MOSFET here which will be paused to drive the motor, and then here you have sensors for the input conditions, and then you have here the input of a remote controller. But first, as usual, our text. Right, electronic waste benefit. Our philosophy is always use as much waste as possible. If you can get up to 90%, the better. 90% electronic waste. Someone would say, okay, PIC is difficult to get as a waste. There is a lot of PIC microcontrollers in the waste bin. Most of them still working. And also remember, please, the F series is the one that you can reprogram. The C is a one-time programmable microcontroller. You can't reprogram it. So look for the F versions. If you can get the same number like I have used, the better. If you can get different and you can get the software to write a program for that, it's still okay. And now back to our philosophy. The electronic waste benefit philosophy: use as much as possible the recycled material. Now, before then, safety. Electricity needs experience. It can kill. So be with someone who has experience if you are not very much knowledgeable. You need background of electronics. It's assumed that you already know something about electronics, or you have a mentor around you. 10 years and more is expected. Please note, this is just a share. It's not a lesson on electronics. There's a lot of literature on the net for learning electronics. What is a resistor or that? No, we don't do here. This is a description of the circuit, how it works. Philosophy: use much waste as possible. This you can use as a training aid. You can use it at home. You can actually automate your door. You can automate your gate. You can automate almost anything that is a door that you can remote power. You can open and close remotely. You can use it for industrial gates. You can use it at home. You can use whatever for machines, or that where the human interaction must be done remotely. Now, required resources as usual, like the circuit number 2, circuit number 3, a computer with a 9-PIC port if you are using the JDM or the other programmers. If you are using a PIC2 or PIC3, it's a USB based, much for the new laptops and PCs. It's okay. Power supply and all that. Softwares, PIC PGM is best. I've been using it. This circuit is now done in an LD micro ladder programming software. I don't know if I should really go into the details of how I did it, because I did it some time ago, and some of the parts I don't remember what I did and why I did it, but I'll try to explain what was happening there if I can remember. The simulation software is Proteus Development Suite. You can download a free version, but you can use another simulation software. Just simulations just to show the circuit works. Then flow code, well, no, not here. It's not going to use flow code. So your time, your patience, your passion, your dedication, yourself. I hope you enjoy electronics. Thank you. So back to our circuit. This is how it works. Let me try to zoom it a bit here. What's happening here? The other part is just power supply. Remember, there's negative and positive at the ends, so they are zoomed out. Right, now this is what it has. It has a close limit switch. This limit switch senses when the door is closed or the gate is closed. Let's use the gate as an example. Here, the overload sensor. If the gate maybe is hitting an object on the way or is trying to squash something, it must stop and raise an alarm. Maybe I did not include the alarm circuit or the alarm program here, but you can do that. You can add an alarm program, but it must stop and raise an alarm and stop. With this program, I have done it that it stops until human interaction. It doesn't automate anything, it just stops there. Then if there's an obstruction, you remember, if the door you open and then the car, maybe you delay a bit and then the car is passing through, or you, the person is trying to get out or get in, and the door is now coming and maybe it's close enough to hit, it must sense that there is an object on the way and stop and open, reopen, because this normally is put for closing, the closing time. Then there is the open limit switch. Open limit switch when the door or the gate has reached the end. When open, fully open, it must operate a limit switch. And within the program, I've actually included the time, which you can actually adjust as well, the time of opening and time of closing. After that time is elapsed, it must stop, whether there is a limit switch or not. This is a fault guard, because the limit switches may fail, so it must stop by itself, or the limit switch and the overload sensor will fail, because the overload sensor is the load. When it reaches an object, it must stop driving, otherwise it will bend the motor or whatever, damage the drive system. Yeah, but it's rare that you find the limit switches and the overload sensor failing. It can happen, but not usual. Now, always there are brake sensors. These sensors are brake sensors. It's an alarm setup, it's an alarm system, it's a security system. They are brake sensors, because naturally things tend to break, so we use brake sensors. You rather have a limit switch failing to make rather than failing to break. This is because if it fails to make when it's just supposed to stop the gate, then you have a problem. But because things tend to break, it's easier that break. If it's broken, it sees the gate is now closed. So this is the philosophy of security systems, brakes, sensors. Well, the remote is actually a mech, because this is human operated. It is a remote sensor, remote switch. You operate it. If it fails to make, no, maybe, yeah. But you can also make it as a brake sensor. It's still okay. Break it, but if you break it, you always have a problem of they are always fading. So you rather make it a switch, right? And the remote can be done as a keypad system, like the remember the locking system that we did in circuit number 1. Use a locking system here, or you use a keypad, a card, or whatever to open and close the gate. So you can modify and play around. Now here the relays, the setup here, the program runs this relay driver. So our motor, depending on the direction that you choose, anti-clockwise is opening, so clockwise is closing. So if it's turning anti-clockwise, it's opening. When it's turning clockwise, it's closing. That is according to this simulation that will show you. Now the relays, there are only two relays, as you can see. In a normal condition, when everything is stopped, the gate is not moving, it's not opening, it's not closing, the motor is just short around. So do I remember which one is the closed relay or the open relay? Well, we'll see on the simulation which one is closed or which one is the open relay. So they alternate, but the relay comes in before the motor starts. You will see that there's a delay here when the relay operates and then when the motor starts to run. It's because you want to protect the contacts of the relay. This MOSFET will only start to switch after programmed 1 second that the relay has made a contact. So it makes contact, then starts to run the motor. So you can see here, if it makes contact with a positive supply for the motor, not for the circuit. The controller is its own power, the motor and the relay is their own power. So if this one operates, there's a positive here, comes through the motor, comes here, goes to negative through the MOSFET. So the MOSFET is switching negative. So only one relay is operated at a given time. So when this one is on, it's maybe closing or opening, and then this one is off, gives the negative. And then the other time when this one is open operated, it gives a positive here, this side now, and then this one goes to negative. So either this is positive or it's negative at a given time. So this is a bidirectional motor, a DC motor. You can put any potential, it's reversible. That's one critical area. So we go on to our simulation. That's the circuit, is there on the shared folders. Right, so now this is our circuit. Let me try to zoom it if I can. I doubt if I can zoom it so that we see. Right, no, we can't. Okay, anyway, I think it's visible enough. Right, this is our circuit for simulation, pretty much like the practical circuit anyway. So we have our sensors here. Now okay, so what is the state? The state is the door is closed or the gate is closed. Now you want to open it, so remote in. You see this one actually operates and the motor is turning anti-clockwise. So anti-clockwise is opening. When you zoom it, you see anti-clockwise opening. And this one, you have seen the delay there. There was a small delay, before the motor starts running. So it's running, it's opening until it reaches an open limit switch. So when open limit switch, it reaches, it opens. You can leave this one open or you can close it. When it operates, it stops. There's a timer that it will actually auto close. There is a program that it will start to auto close, but should wait for that, maybe not. Let's try to close it by remote. We close it by remote, delay a bit, and then starts. You see now this is the close relay, this is the open relay. Right, it's now closing. This one must have operated back, because when the motor starts to move, it operates back. It doesn't matter because, well, it's the program. It is intelligent to check that. Now then it reaches closed state now, so it can still remain open. It's now closed. Right, so that's what it is. Now suppose you open and then delay and then starts to open. So this one makes it's now opening. Will the infrared affect? No, it will not affect. Overload? Yes, overload will affect. So it stops. This overload will stop until you try to do something. But would it do something if the overload is still there? No, it will not. It will not. No, until the overload goes away. So overload. Okay, now you see. Oh, if you click twice, just immediately it will not respond because it gives some seconds before for bounce protection. So now it's what is it doing? It's closing. It's closing. It's closing. It's closing. So closes. Suppose it's closing. Let's say there is an obstruction. It stops. So it will stay there as long as the obstruction is there. For the sake of time, I put it back so it will time until it will start to auto close. Right, so start to auto close. You can change these times on the program. I'll show you how. Right, so this is the auto close. Now you can stop it using a remote. So yeah, there is, I don't remember doing this. Suppose it was closing and then you operate a remote. Oh, it will stop. And doubt if I program that it actually checks again the limit switch for the close. No, it doesn't. You have to manually close it. Open and then stop, then close it properly. Leave it to close until it operates a close limit switch by itself. So that's, well, you can perfect it if you want. For normal working, I think this works, but well, I didn't like it, but I didn't have time to really try out other things. You'll see the program is too long and sometimes just excuses. Okay, anyway, right, so this is how it does. So you have these sensors in a break format. So this is pretty much about it. A delay here to protect the contacts. Here the infrared sensor will stop and then it will auto close. If it opens and then you leave it, it will auto close. Go on the auto, you can test that one and improve the program if you want. Right, so now we must now open the program to check. I've used LD Micro version 4.1.2. It's free on the net. You can download it, and it's a simple program that runs here. You can see I'm going into my folder and opening it and say open. Right, what do I open? Now it's, did I stop the program? Maybe that's the reason. Yeah, program is not stopped. Now I must choose which program I must open. I'll open that one, and where is it? Here. Right, here is the program. Oh gosh, I don't remember this much. This is the remote input. One shot, so that if you press once, it gives you that shot, one shot. It doesn't respond twice quickly. Right, the next time I close, this is the open relay, the open output of the microcontroller. Then it activates internal relay here. It's opening, tells it's opening, and this is the time to open delay, which you can change. Time 30 seconds. You can change this. Whether the limit switch activates or not, this is the time it takes to open. You can change that. And then what else is very important? Time to auto close. You can change this one as well. This is the time it takes to auto close. If you leave it open, and then it should auto close. And then also you see here the time to auto close it, and then if the infrared obstruction is there, it must also auto close. This is the time it takes to auto close, 30 seconds. You can change that. And then the other programs, this is a ladder program. You can use this one to train yourself to program PLCs. It's a nice program, but made for PIC programmers. Once again, not here sharing how to use an LD ladder. There's enough literature on the net for that. Learn how to use it. It has improved. It has gone from what it was long time to what it is now. You can do much more programming with this for PIC and AVR microcontrollers. And remember, AVR is now under microchip, so there's much more of AVR than the PIC on these ones. So you can check here are the microcontrollers that you can do. You can check here more of AVR. This is an open source program where people are contributing to it. You can check on the website for it. Okay, right. So back to our program. So remember the terms that you can change around here, right? And then this T wait 10 seconds. Okay, other wait, other next. Okay, what is it waiting for? I think it's the waiting time. Oh, I don't remember that much. What is this time for waiting? It is, but it has to wait for something. Try to auto close. Okay, it's the time it wastes. It wastes time to close. Okay, this is closing time. So this wait is the auto close for time. 20 seconds. No, yeah. Auto close time. This is time to close. And this is time to auto close. Okay, it takes to auto close. Maybe this one was also secondary infrared. Oh, okay. I remember. So if there is an infrared input here, it takes 20 seconds. It's different from the auto close. Okay, time to wait to auto close after the infrared input, the obstruction input, right? Now the T flip-flop is actually just a signal for a switching signal for the MOSFET. It flips, that is on, flops out, flips on, flops out, but it must wait 1 second before it starts to do that. This is the relay wait. Relay wait here 1 second. You can change this one also. You can change also the time here, and remember you can actually use the pulse width modulation. The PWM function is there to actually drive the MOSFET. I've not tried that one out. I think it's simpler, and you can change the duty cycle and all that to drive the MOSFET so that you run efficiently. But this maybe is another way of doing it. Okay, so this is pretty much the program. Yeah, to go into detail of it, maybe you learn the LD ladder program, and then you can actually be able to read this program and improve it, and actually maybe correct somewhere and actually make it more efficient, because my programs normally they are not efficient. I just do what I can do at that time and never really go back and replenish and make it more like an efficient program, because you will find sometimes maybe here's a repetition or something like that. So you can develop the program and make it more look like nice and all that, but this works. As you can see, it was actually works. So you compile the program here, compile, and then it produces AX program. I'm sure it produces AX, and well, here's a number of, I think it's an assembly program and all that you can learn about LD ladder program. So what I'm interested mostly is the X program, because that's the code that I put into my microcontroller. Here also, here's the inputs and all that. You must actually be choosing which pin is what here when you say like other next set or other close, what pin you are using on the other set. It's only okay, cancel. Want to check the output pin for a controller. Okay, this is a pin on the microcontroller, so it will actually ask you which pin do you want to use here, so that you have to put it in here, the whatever, the inputs and all the internals, what, and here is the PIC that I've chosen to use. Remember, this program you can also actually straight run on PIC16F819 straight on. Just take this one made for 819. I've used it straight on 88 without change, if I remember very well. But otherwise you can change because the 88 is there as well. Just change the PIC to 88. I think that's the nice thing about the microcontroller. Sometimes the programs you can just take and run it, especially if it's just straight digital. If the memory maps and everything are the same, they pretty much run on the PIC on different PICs. So here's the processor, whatever. So that's LD micro. And what else? I think that's pretty much about the gate controller. This circuit works, and now you can do it much better. You can do it with even a PLC. This is a PLC actually, because this is a programmable logic controller anyway. The PIC is a PLC in any case. So yeah, ladder programming. Yeah, that's not bad maybe, but it's good. This program is good. I like it. It's simple, straightforward. It's good for us people who can't program in C. We are hardware people, we are not software people, so I like it. Okay, right. So feedback, please, as always, tauramirimi@gmail.com. And these folders are on Google Docs. I've shared this circuit on Google Docs. Feedback, positive, negative, welcome. Thank you very much for your time. Enjoy.